Can you see me? Hello? Is this working? Okay, it started now. It started now. I don't know what happened before. But the thing is, I cannot see myself when I'm doing this. Okay, don't spoil the problem to me. I need viewers. Here we can see viewers. Let me update that one. Let me update this one. Let me update that count. You know how to update that count? I can just go here and try to do this. We have font, we have color. Is black better? I think white's better. We have 21 viewers. Damn, that's nice. I cannot see viewers. I think you guys can see viewers. But yeah, that's one thing. And can you guys see chat? Okay, it started now. It started now. I don't know what happened before. Why can't we see chat? I can just have one. It started now. I don't know what happened before. Yeah, don't spoil that to me. Now, I don't know what happened before. Sure, I'm going to LeetCode and talk something, and then I'll do one Codeforces problem too, okay? Because I'm having this fire. I should not lose that. Start timer. Timer started, guys. Medium question. Companies. Damn. Google. What about Apple? Oh, only Google pops up. I thought it's because I clicked it popped up. You are given an integer, number of users, representing the total number of users, and an array events of size n cross 3. We have an integer number of users and the total number of users and an array of events n cross 3. If you notice, this number of users is different from this n. See, I'm smart. I'm obviously smart to identify that this number of users is not equals to this n, right? Because this is different and this is different. You cannot just assume if both of them are same, they would have used n here itself, right? Someone told me to keep the stream short, so I'm trying to extend it a bit. Each events of I can be either of the following two types. Message event, damn, this seems irritating to me, right? So all these events of n cross 3, they can either be message two types. Message timestamp 1 mentions string. This feels like my work, I'm just joking. Timestamp I mentions string I. Okay, this event indicates that a set of, see, the problem has some terms and everything. You have to read it and then you have to understand it a bit mathematically. I think this was written on Umnik's blog too. First you have to understand it a bit mathematically. I mean, further you have to read the whole problem and then you will understand, okay, what's the structure. See, I can start now. Really? We need premium for that. Scam. Sorry guys, I don't want to waste time, but yeah, we have to be cool. You guys should learn to be cool, okay? Cool in the sense not cool, cool in the sense chill, like, because in problem solving what happens most of the time is we feel anxious, like we feel like I can't solve it, I can't solve it, I can't solve it, I can't solve it. If we feel anxious, like we cannot go further, like we have to be calm, we have to see the problem from above, okay? We have to see the problem from above. I'm not wasting time, okay? Yeah. The mentioned string I can contain one of the following tokens: ID, number, where number is an integer in range 0, number of users minus 1. So it has an ID which is number, I guess. It starts with ID and then it will be a number. Okay. That the mentioned string. There can be multiple IDs separated by a single white space, may contain duplicates. This can mention even the offline users. I didn't understand still what it is, but yeah. All means mentions all users. Here means, okay, this is what we do in the Slack @ right? Here means mentions all online users. Mention string, that's why it's called mention string, okay? We have these users and we have these events coming up. This message event comes at this timestamp, and then we have another event which is offline event. This event indicates the user ID had become offline at Inta. I use Telugu at timestamp. I use Telugu, sorry. I'm not talking properly, I'm talking in a weird way. I don't know why. For 60 time units, the user will automatically be online again at the timestamp I. So he goes and then he comes. So he offline for 60 minutes, like going on a break to do something. Written and so we know initially all are online. Is it? Should we take that for granted that upgrade to cloud saving? It's all bad. Like no one provides a good service these days. Streamlabs is not open source, but it was built on something, right? OBS, and OBS is open source, right? So I have to use OBS to. Are there any good programmers here? I think I should try that. I should try to get the chat here using OBS, because if Streamlabs is built on OBS, I should be able to do that. But I am bad at programming. I can only solve stupid problems. I cannot build real things, right? I will learn maybe. I'm working, right? I'll learn slowly. The user will automatically be online again at here. So here they go offline, and after 60 minutes they are online again. So if you take this minute, he's offline, and then after plus 60 is online. Return an array mentions, where mentions of I represents the number of mentions the user with ID I has across all message events. All users are initially online. Okay, this was given here. And if a user goes offline and comes back online, their status change is processed before handling any message event that occurs at the same timestamp. The status change is processed before handling any message event occurred at the same timestamp. So what does that mean? Is if he's going offline in this event, first he goes offline and then it will be measured. Okay, so at the beginning he goes offline, or at the beginning he comes online. At the beginning of this moment he comes online. Okay, so now we have to find this for all users. First look at one particular user, how the problem will look for that particular user. Okay, among all these things, let's see. If you look at one particular user, that guy is staying, he goes, he comes, he staying, maybe he goes, he comes. Okay, does this offline events merge? Because they start off, they're from here to here, right? So I think these things should not merge. that user can be mentioned multiple times in a single message event, and each mention should be counted separately. Okay, that's fine. And is there a constraint on that? So it is guaranteed that he's online at the time the event occurs. So whenever this offline event comes, so this statement shows that if he goes online, he comes back here. This statement shows that they don't intersect. Okay, so now I can see one guy. He's online initially, he went offline, and then again this statement guarantees that again he came back like that, and then he came back and like that. So let's look at this guy. Okay, if you look at this guy, there are some mentions. Okay, all online users, this can even mention offline users. So these mentions are bad, right? I mean, we have to count them separately, I guess. If all happens, we have to count that all too. If this happens, we have to count that one too, right? Clarity is important before going on coding and doing something. Okay, so across all message events, so this is a message event, this is a message event, even if they occur at same timestamp, we have to count them. So these three things are also independent. Okay, these three things independent. What I mean by independent, users are independent. The problem is entirely independent. For one particular user, you can look how many times these things will affect him. Okay, so these things doesn't make any sense, right? That's its contribution, that's it. Also this doesn't matter, it's again same contribution. So these two things are easy. Only this is a bit tricky, right? Only this is a bit tricky. Here, when a here comes, so these two are simple. This adds +1 to our user, this adds plus number of times our user has occurred in that. These two can be computed for everyone easily. We only have to worry about this one. Okay, we only have to worry about this one. So for our guy, we want number of here. Whenever he is online, all of them will increase. But whenever he is offline, let's look at them. Why look at them? Because he is online all the time. Only those times he's offline, right? So look at offline. All the heres that are occurring minus number of heres that are in between the offline time is what we want, right? So we have to see number of heres in this duration for that user, and then he has another time frame like where he is offline. We have to count. Let me write. Sorry for not writing at all. Look at one user. Okay, we need all mentions. Mention type 1. Mention type 1 is simple. Just count number of x in that. Just do plus done. Here, all here that occurred online we should count. Okay, this can be written as total here minus here occurred when he is offline. When he is offline is this one, and then this one, they don't intersect. So you just want within this range, what are the number of heres? That's it. It's like if you have all the heres in a line, sorted, this is just a range sum. Like this is just some sum from here to here. That's it. So let's see timestamps, constraints of timestamps. If it is small, we can just use sliding window, because 60 or like 60, right? We can use sliding window itself if it is small. What is events I of 1? That is timestamp. So for each timestamp we want, so let's say this is an array. For each timestamp, maintain for each time here count. Now for some user, you just need sum within a range, right? You can do prefix sum, or you can do window, you can do sliding window, you can do prefix sum, you can do anything you want. So this is an easy problem, right? Say guys. Is there anyone? I'll do one Codeforces. I cannot see chat. Yeah, I will go to Codeforces. Sorry for this, but yeah, I will go to Codeforces instantly. Let me code this quick. Yeah, everyone knows this one, but let me code this quick. I'm just checking if the timestamps are in increasing order, but it doesn't matter to us, right? Now, I'll try to go quicker and then I'll do one Codeforces, don't worry. I'm sorry for this shit. So we are trying to see for each timestamp how many people are here. And what is this one? So I'm taking two characters in, that will take ID, and then I'll take an integer. Okay. So this will give us ID, right? So now we have ID. So now we have ID. I hope it doesn't take too much time. Now what should we do? I hope it compiles still here. I never used STOI, that's why. How can I do this? This is stupid. Like, I don't know how to do this. How to break a string? One minute. I want the next character. So if it is at the end, or f of I plus 1 equals to this should collect. Codeforces. I think someone gave me a problem. By the time you guys can try to think about that problem, okay? At least. Or try to code this itself, right? So now we can see that our IDs will be correct, 1, 0, okay. So now what will I do? So all was done now, and this was done now. All is done. Let me increase whenever here comes. Let's also increase all here too, because we are anyway going to subtract them. Okay, we are increasing all here too. Now we have to subtract here's that are falling within those things, right? For that I will make this prefix array. I will make this has prefix array, okay? Maximum 100 times 100, right? Each of them. So it won't exceed. Now for auto f, again events, if f of 0 not equals to offline, continue. So now we have int t equals to stoi of f of 1, int id equals to stoi of f of 2. Okay, these are clear, these are simple. Now what should I do? From this time to that time we have to subtract, that's it, right? So time cannot be 0, so we can just do that. Answer of id minus equals to, what should we subtract? Here of t plus 59 minus here of t minus 1. That's what we have to subtract, right? And then we are good, and then we are done. See? How to go to problem now? It can be 60, right? Why am I here? Move this here. It's not allowing me to do. Too simple. What about 20 minutes? 33 minutes. Problem. Okay. I will choose some random thing in 2400 because 2400s are not that difficult, I hope. See, for ICPC, all you have to do is try a problem calmly. try a problem calmly, because on Codeforces you try to be like guess, but ICPC needs time, needs calmness. You have to see the problem, few problems, because I created a puzzle. Let's compare this problem with this problem. The previous problem, it didn't have anything good. It never had anything good. All it had was to remove these things. Instead of seeing what can be done, see it as all minus removals. That's the idea. Nothing else is difficult, because idea is just that. Everything else is work, and work we can do slowly, right? Okay, leave that. Let me read this problem. Okay, let's read this problem, guys. Read seriously, please. Okay, don't slack. Read the problem well, because ICPC also demands a lot of not getting scared thing. Because ICPC, if you really don't get scared, you may solve some problem that no one else is solving, because it may look scary. Okay, it may just look scary. Okay, so are you guys here? Are you guys trying? Give me a W if you guys are trying, because I'm not at all interacting, right? Guys, give a W if you are following. I need more W's. Just acknowledge. Yeah. Not W. Okay. You should not get scared. We won't get scared. We'll read the problem well. Okay. Nigga, I don't care if you are my number one fan. I don't care if you got 75 XP. Oh, everyone has 75 XP. Okay. Give a W, or else I'll remove you. Choose. Choose what you want. Now I'm asking this guy called Cart Blaze 55492. Okay, Light. I got NFWs. Light. Fine, NFWs. Can you see the problem? Can you see the problem? Okay, we got the spammer. Yeah. Is it lagging? Guys, read the problem. Let me help you read the problem. Okay, see the problem. Try your best. Don't get scared of anything. Okay, let's read. It seems a nice problem, because there is some ratio. It seems nice. Let's read and then let's judge. Maybe it's not that nice, but let's try. Let's try first. You have been gifted a puzzle where each piece of this puzzle is a square with a side of length 1. You can glue any picture onto this puzzle, cut it, and obtain an almost ordinary jigsaw puzzle in pieces in such a way that the following conditions are met. I'm not understanding anything, but let's read the problem. The pieces are aligned in parallel to coordinate axis. The pieces together do not overlap each other. All pieces form a single connected component, that is, there exists a path where each to consecutive P by S. The number of pieces does not exceed 500,000. Can you handle it? So see the problem. This is not some problem you cannot attempt, right? This is problem where you have to try to come up with a solution. You have to try, you have to think, and then you have to come up with a solution that always works. See the problem. It doesn't need something out of your something complex, some extraordinary idea. It's like trying to work on the problem, trying to somehow get some structure, some pattern that always works. Whatever the S is, whatever the P is, the code that you submit will work. You have to just come up with such a thing. So is this not tryable? Is this question not tryable? Guys, this question is tryable, right? So this seems working, right? Okay, we have only 11 viewers now. That's bad. So guys, hello. I hope it's back and it's good. Is it better now? I'm not sleeping properly at all. I'm not sleeping properly for 2-3 days. That's why it's bad. Actually, it's not that good. I got here and here something black ones, like eye bags, whatever they are called. Bro, Sujana, I'll remove you if you act weird, okay? We are here. Can you handle it? Okay. P comma S is less than or equals to 50, and we are allowed to use these many pieces, okay? The ratio of the perimeter to the component to the area of this component is P by S. If you see this one, what is the area and perimeter? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18 is the area. Okay. Oops, I cannot show any of my personal things. Damn, that was scary for a moment. Yeah, here 18 is the area. S is 18 and the perimeter is 1. Perimeter is 1, 2, 3, 4, 5. You guys see this as a square, right? It's 5. 4 times of 5 is perimeter. 4 times of pi by 18. No, we have to measure the perimeter in a normal sense. Okay, 1, 2, 3, 4, 5, 9, 10, 11. So it's 11 into 2. 11 into 2 by 9 into 2. 11 by 19. Okay. We want a way in which we can use these many things and be able to. So we have S less than or equals to this much. We have S less than or equals to this much, and we need P by S equals to anything in 50 comma 50 is to 50. So you should write a code, a process or a pattern that works for any x is to y, where 1 less than or equals to x less than or equals to 50 and 1 less than or equals to y less than or equals to 50. How do you do that? How does perimeter be? Is my stream happening? So guys, try seriously, please. Okay, try seriously. You have to try seriously. You have to think of perimeter. I'm not thinking, but you have to think. How can perimeter be like? You have to think, really think. Okay. What happens when two things merge? You have to think. It should be connected. Okay. connected. Okay, what happens when two things get connected? So what if it is impossible? If it is impossible, you have to output -1. And you have 10 test cases of these things. If it is impossible, you have to output -1. If it's possible, you have to output first your k and then you have to output the... So guys, this is a good problem, okay? If it's a good problem, so try it well. It's a good problem, right? Guys, don't ask other questions. I will remove if you guys are not trying hard. If you guys are not trying properly, I will remove. It's a good problem. It's a bit higher rated, but it's tryable. So try your best, give your best, okay? You have to find... The problem is, you won't come up with different patterns for different things. You will come up with one pattern that works all the time, okay? So just try to cover most of the things, okay? What will be covered if you just keep them in a line? What will be covered here? What if you just do rectangles? What all will be covered if you just do rectangles? Rectangles of size L cross B. Then you can cover all of L plus B by L times B, right? Rectangles cover this. So for some area, you have equals to L times B, let's say, okay? You have minimum perimeter probably L plus B, okay? And max perimeter is, you can get, keep them in a line that gives maximum perimeter, right? L into B plus 1 L into B twice plus 2. I think this is the maximum perimeter, right? Why? Everything should be connected, right? So you have one thing. Let's take anything. Something else is connected to that. There, one edge is shared. How do you prove that? Take one thing, okay? Now something else is connected to this. So an edge is shared. What all is covered here? What all is covered times P? This is minimum perimeter, this is maximum perimeter value. So leave this one because this is L into B, but for NS you can surely say P less than or equals to 2 plus 2S, and P by S if you put everything in a line, perimeter is 2 times S plus 2 by S. So this can be told always. So if P by S is, if P by S is 3, answer is -1. This you can say. So guys, we have to solve the problem perfectly. We have to solve the problem. If you see, okay, I have a logical point. See, let's believe that proofs are simple. If you believe, okay, means there is a way to show that it's either possible or impossible. Means there is a pattern that covers most things. There is a simple thing that covers most. Otherwise, we cannot come up with logic that something may be missed out, right? Some pattern covers most of the things. So because if there is a simple proof, this must exist, okay? Because if there is a simple proof, this must exist, because then we can say, okay, all of them are covered and these things are impossible. So there is a way in which we can get anything, okay? So let's fix this. Can we get all other parameters for a given s? Someone has told me something, right? So let's start from maximum. Let's start from max, okay? Can we keep reducing perimeter p by 1? So take this one, place it here. What happens then? If you take this one and place it here, what happens? Nothing happens. Right? Okay, see, we can reduce perimeter like this. Well, you have this, right? You have this, right? Longest one. Try to look at like this and then try to form this. Here something happens. I think even this is full. Should I try to clear cache or something? How to clear all of them? More of them. Okay, for a given s, if you place it here, nothing happens. Why? Still only one is being shared by twice, right? But if you form like this, now what happened? See, here, if you look at per square, two things is being shared. This is being shared. You are also losing these two things. So for a given s, look, p equals to total edges minus shared edges. This will make it, shared edges will be losing two things, right? This will be 4 times s minus 2 times shared. Okay, so this will always be 4 minus 2 times shared by s. Okay, p is always in this format. For a given s, p is always in this format. You cannot get odd by s. You cannot get this. This is one thing necessary. For anyone can say, okay, yeah bro, if you try it can become. I don't think there is a universal law that's written somewhere, or like in this universe there exists a physics law. So now what? So now you see, before number of shared, let's look at number of shared in this pattern. Number of shared edges is n minus 1, because to be connected at least this much should happen, right? To be connected at least this much should happen, number of shared edges. That's why perimeter here is 4. Can we reduce number of shared edges? See, this thick edges, this black edges, this dark black ones are shared. We are removing them n minus 2, okay, for a given s. Can we make it further? Can we make it further? It's again n probably, okay. Why again n? Because this thing has just been moved like this. So it's again n, and then you're reducing it further. So you're increasing it further. So n minus 1, it started at n minus 1. It became n. And then it can become, if you follow the same pattern, it can become n plus 2 up to so on. Till where can we go? We can come till here. Okay. How? Maybe we can go like that. Further. More things. Can we always keep them as a rectangle of size like that and top row being empty? Can we always do that? Can we always make them like that is what I mean. What I mean is, like, can we always do something like that? What I meant was, whatever the value is, whatever the rectangle is, can you always make it like this pattern? What pattern? My question is, can you always make it into something like this cross this and some array being left out without changing this number? If we can do that, we have all the possibilities, right? We know what all are possible. If you can get that logic that this number of shared edges, you can always make them into this pattern. Or if you get that number of shared edges, anything is possible. Okay. How can you do that? So if there is something that is shared among three things, okay. If there is some square, only one of them is shared. If you move that square to a place where two things can be shared, then you can reduce one. If you have a square that is being in which only one is being shared, and you can move that to some other place, you increased shared edges by 1. See, as long as this is possible, you can increase perimeter. You can increase shared edges, and you can increase perimeter. And we can make L shape too. So guys, we are getting somewhere, right? You mean like some L shape like this? You mean like some L shape is enough for anything, right? Reduce perimeter or increase. Can we keep increasing number of shared edges? Can we keep? This is a question we have, right? So how can we do that always? Like maybe let's start with an L shape itself, as someone is suggesting, and try to form it further and further. I mean, it's not about L shape too, but like if you are here, I think it's need not even be L. Like whatever I have told is fine. Like what I'm saying is, what I am saying is we can always come here is what I am saying. We can always come to something like this is what I am saying. We can always come to something like that. Okay. What I mean is we can always come to something like that is what I mean. We can always reduce probably. So how can we reduce one more here? Take these two, try to move here. Okay. And then wait, now this is not reducing, right? But this will reduce. See here we removed two shared edges, we added two shared edges. Okay. So what can we say? Can we always reduce? Like until where can we go? What if we cannot form a rectangle? Or rectangle's the best? Okay, if rectangles are the best, okay, if rectangles are the best, what's the minimum parameter? What's the minimum perimeter for a rectangle? It is splitting them equal, right? So for s equals to k times k, do we have viewers? Guys, just confirm me this. Can we always come to this structure? Can we always come to this structure? The structure is a rectangle plus one row of the rectangle being empty. If this is true, we can solve the problem. How? If this is true, if we can always come here, then how can we solve the problem? Then we can try to brute force on this side. Okay, we'll try to brute force on this side. And once we have this side on both, okay, we can fix this side. Now this is coefficient, this is remainder, right? So we can know what happens here. We can fix this one and then we can brute force if you know S. So can we always come to this structure is what I mean without changing perimeter at all. Okay, if it is not following this structure, what does that mean? Let's just take row 0. Okay, let's just take row 0. If row 1 is not having equal things, like if row 2 is not having equal, can you always move something there if row 2 is not having equal without changing perimeter is the question. Okay, probably yes. What logic can we use to show that? Always tried coming backward before, that was working a bit, but so let's see our initial logic itself. There, place this here, nothing changes, and place this here, place this here and place this here, nothing changes again, nothing changed again, right? Now what do we do? Place that here, place this here, again nothing changed, right? I'm not able to do anything. Nothing changed, nothing changed. Now we have +1. See, when we have gone from here to here, now we got +1. Here now only this one is there, now these two are, we got +1. Now again see, 2 has been removed, 2 has been formed, 2 has been removed, 2 has been formed, 1 has been removed, 1 has been formed. Right, but maybe let's keep going. So it seems if you keep on continuing this process, now there is no point in doing this further. Why? We have reached a point. Now doing this again there's no point. Why? It's already almost 5 cross 5. You cannot put things again on top of this. So see, I think this idea is right. Like, not idea, like if we fix this breadth, see what are we doing? Whenever we fix the breadth, we are trying to do remainder, right? The same thing that I told before. We are always able to reduce further. So what is this pattern like? If we remove this two, what is this pattern? It's like trying to make them equal, and then we go further, nothing's reduced. If we go now, 2 things are reduced. So we are reducing this length, and we are always reducing 1 at max. If you see, we are always reducing 1. See. Now +2 happened. 1 has been reduced, 2 have been happened. So if this is minimum, and if that is maximum, there is a way to always keep on going till here. Okay, so our pattern has worked, the pattern that I told. Is anyone following? See, all perimeters can be just formed with this type of structures. Okay. You fill some rows. Okay, and then this will be removed. All perimeters can be formed like that. All perimeters. Why? If from here there is a way, 2 has been removed, 2 has been placed. Okay. 2 has been removed, 2 has been placed. Perimeter not changed. 2 has been removed, 2 has been placed. 1 has been removed, 2 has been placed. So there is a way to always remove them. See, if you know what is minimum, you can always go there. So if minimum is in this format, if minimum is in this format, so guys, we have to use logic correctly, okay? We have to use logic correctly. So if minimum is in this format, if you can get minimum in this format, you can get everything from minimum to maximum. Is that clear? So what are we doing here? We are able to go from one thing. So what we have done, we are brute forcing on this length very clearly. We are brute forcing on this length very clearly, like we are reducing this length one by one. If you see, I'll show for this example. We will reduce this length one by one. So the length is being reduced one by one. So what do I mean by that? This length is being reduced one by one without changing anything. For every length, we are visiting this pattern. If this is bigger, if this side is bigger than this side, what have we done? We have removed this side. We have removed smaller side and we are placing it on a bigger side. See, logic working out very well. We removed a smaller side and we are placing it on a bigger side. That's always possible to do. That thing is always possible to do. But when you do that, now when you go from here to here, +1 have happened. See, we are going, if minimum is like that, then we can always do that. Again, what were we doing? We are not changing anything. We are trying to go to this thing. What I'm trying to say is, we will always approach such a thing. If you fix this one, we will always approach this one. We will always approach, if you fix this, we will always touch this thing. If you fix this, we will always touch this. Okay. Do you guys get what I mean? This is unique. If you fix this thing, the structure is unique. Why? This is quotient. This is remainder. Right. So look at the structure. L and L into Q plus R. If you look at this structure, there is a way to get all these structures and everything in between. Do you guys get what I mean? Like the video, guys. It's disappointing, right? I mean, no viewers. Why am I doing this on a Friday night? Do you have no life? When people are outside partying, some guy would be doing something to a girl. And me here, talking to you people, moving squads. What is this? What is this? Is this even living? So guys, do you see that? We are going from one by one. And most of the fuck is that? We are going from one by one. Do you guys agree that? So that's the simple structure. And we are able to prove things well. Why are we able to prove things well? This movement is possible because the other side is greater than this side. Okay, the other side is greater than this side. And for that reason, this movement was possible. Okay. Probably this is the answer. This is probably the answer. I could have made this assumption long back. See from the video. See from the beginning, okay? Guys, don't irritate me, okay? So do you guys agree to this? Do you guys agree? Yeah, we have to go for the simplest guess, right? See, from golden rules, it comes that there is a pattern that covers most things. So what is a simple pattern that covers most things? What is a simple pattern that covers more things? Rectangle. If not rectangle, remove one row. It's a guess, but it's a simple guess. It's not like some complicated thing, right? And we are able to prove it well. We are able to prove it well by removing one by one. See, guessing comes from trying to guess something simple without getting scared. Is this pattern difficult? Because the problem is not yet done. This may be true. This may be true. Okay. This might be true. And when L times Q plus R, L being root S or something, might be optimal. Maybe. Like when you make it like root S, one thing root S. What do I mean by root S? So when both of them are almost equal, okay, when both are almost equal, L comma Q or L comma Q differ by at most 1, okay, which will make it L into L plus 1, sorry, L into L plus 1, Q being smaller, okay, Q being smaller, L into, it's either L into L plus R or L into L minus 1 plus R or something like that. Okay. They differ by at most 1. Why? If this one is greater than this one, we can always move these things here, and then you have reduced it. Now you want to move all these things, right? You can start from below if you want. Sometimes you have to start from below. Now you haven't reduced anything, but now you are reducing. So what I mean is it's L into L plus 1 almost. Wait a minute. Here it might appear like you are increasing, but you can move both of them and then you can reduce it. So okay, now how to solve the problem? Let's assume that. Now how to solve the problem? For a given S, is this fixed? This is minimum, right? So guys, we took a lot of time to prove this, but then if you see, it's being stupid. It's being like find minimum P and then from everything from min to max is possible. That's too bad, right? Or you can argue by some other logic. Min cannot have one thing. Min cannot have one square. That I argued it before too. Min cannot have one square this having 3 things and the other square having these two things, because then you can move it from there to there, right? Because of that, min cannot have such things. That also will lead you to this pattern. Lead you to this pattern. Nothing can have something like that. If you have something like this, if you remove that, it must be a square. Why? If it's not a rectangle, there will be something like that. Okay, and then you can place there. So see, you cannot have this, you cannot have this, you cannot have this logically. It's too simple because it's 24. We need not put much logic. 24s are easy actually. I have solved even much difficult ones. So I'm going very slow, but this is not difficult. You can use logic, simple logic. If this is there, if you remove that, ignore this one. You need not even ignore this one. If you can form, if after removing something like that, if you can get these two things, where two things are there and this is empty, you place this there and then you reduce it further. So minimum must be of this pattern. In this pattern, there is no this one, right? There is no this. Is there any other pattern without this? Probably no. Without some single thing. Why? For everything, two things are shared. Oh, there can be such patterns. See here, this is left out. I mean, there can be other patterns too, but they are similar. They are almost similar, okay? There cannot be some different patterns. I mean, there are other patterns, but then they have same weight. They have same goal. Like, they cannot be reduced further. Okay, so now, how do I get this for a given S? How do I get this? So it's an easy guess. Guessing wise, it's an easy one. Because the problem, even after guessing, there is more problem, right? So what is this value? What is the minimum P for a given S? Is it L into L plus this, or L into L minus 1 plus, or is it minimum among this? There is only one L for these two things, okay? Maximum L such that this is possible. Okay, if we know minimum P for a given S, we want P by S, right? Go over S multiples. Okay, you have P into K by S into K. So our capital S is S into K. Now check if P into K falls between P min of S comma P max of S and is of same parity and is even, then it's possible. This is our guess now. This is our guess. This is simple. All you have to do is, can we do this all multiples? Yeah, you can do all multiples. You can go over all multiples. Why? S is 50. S is within 50, and maximum value of S is this. You can go over all multiples. It will take this much time at max. And once you go over all multiples, you have P min and P max. So it's all about what is. Q less than L, okay, plus, like, probably all increase to L, then the problem has ended, because now moving further doesn't make any sense, because it only becomes bigger. If Q is L or Q is equals to L plus R, let's say this is a thing, if it is L, so or this, that's here. You can go further. Let me add few more things. Let me remove, this is perfect example. L is 5, Q is 4. You cannot go further, right? You cannot surely go further. Surely go further because L minus 1. So we want these two things, like maybe it ends up here or it ends up at L into L. So where does it end up at? You can binary search and find that obviously, easily. You can binary search and you can surely binary search and find that. Right, for each S, binary search and find this value already. What's the minimum S, minimum P? You can even do for each L into L, for each L into L minus 1, update all S. Update all S to minimizing to that. You can even okay, now what's the answer here? Answer to this is, answer to L into Q plus R is, you have L into Q, perimeter being L into Q times 2 into L plus Q, okay, plus 4 times R minus 2 times R, right? You have this perimeter plus, look this as 4 times R, not 4 times R, that is okay, this 2 times R is fixed, and then you have R minus 1. Minus R greater than 0, R minus 1 times 2. So this is the value, right? This is 2 times R. The below things are 2 times R, and for the above R you have that. Let me go over all L into L's and all L into L minus 1s and all these ones too. So what would be the complexity of that? So L into L less than or equals to 50,000, right? And then brute force R less than L or less than L minus 1. This is also complexity is of 50,000. So let's just brute force and minimize them. Let's just use both the patterns. Let's just not care. Okay. What's the biggest value? We know already. R equals to 0, Q equals to 1, L equals to N, L equals to I, which would be, even if you use our formula, 2 times of L plus Q, which is Q plus 1 plus I, minus all of them is 0. Let's make it 2 times R. If this formula is right, we are good. And that formula is simple. Okay, initializing that. Let's do L into L. L into L plus R format. Okay, Q is L. Okay, or equals to, let's brute force or. So now int s equals to L into L plus R. Okay, possible parameter equals to 2 into L plus 2 times R minus R greater than 0, R minus 1 else 0. I mean, there are many ways of, if this is correct, there are many ways of solving the problem. If this is wrong, we don't know what is it. This is my claim. Okay, that's my claim. Now we have min p. We know what's max p. Do I even have viewers? I mean, it's an easy problem, but I was just overcomplicating it. You guys can obviously see that I'm overcomplicating it. Not overcomplicating, I'm just taking my time. That's why I'm not good for contests. That's why I'm doing streaming. Which is too bad. S equals to K times S. Okay. What is P possible for this? We want P equals to P times K. We want this thing. Let's just remove first GCDs, okay? Because now we can guarantee that it should be multiples. Otherwise, we cannot guarantee. Unnecessarily, it might have been made big, right? But now there must be multiples of these two things. If GCD has been removed, there must be multiples of these two things. So we are brute forcing everything correctly. So now we have S and now we have P. Okay. If P remainder 2, continue. Because perimeter is even. We have seen that. If perimeter is even, if P min guys, we have to output the thing too. We have to output the thing too. But it's fine. We know the process. What the fuck am I doing with my knee? If min P of what is max P of S? It's just 2 times S plus 2, right? If not of this, continue. Now our problem is done. We have found it. We have found the P, we have found the S. Okay. So now what would I do? I will start from L. And then I will make it Q. because this we have only 10 test cases, we can do whatever we want on this. Wait. If we have only 10 test cases, why did I need this? I needed this because, do we even need this? Can we just do this itself without even doing that? To find this, what would I do? Because this is root S. Okay, this is root S and this can be O of S. So no, so we can't do that. This is root S, but this can be O of S. That may be too big. But if this may be wrong, this shit may be wrong. Our claim is that it will be equal at some. Because this pattern is reducing one by one. It will reduce